Welcome to tonight's video, starting Unit 2, Part 1. We'll start talking about postulates and proofs. Those are terms you're going to hear a lot about in geometry. The definition of a proof is that a series of statements and reasons used to prove a theorem. So a proof is something that we do to prove something is true, and we'll start talking about how we set up a proof later in this chapter. As far as a theorem goes, a theorem is a statement that you can prove. All right, so if we talk about a theorem, it's something that is proved. Like we could actually prove that it's true. And then there are some things in geometry that we just accept to be true, and those are what are called postulates. So a postulate is a statement accepted without proof. So today in this video, we're going to talk about some of the postulates that we're going to use in geometry a lot. And those are things that we just assume to be true, like there's no proof for those. And the first postulate is through any 2 points, there is exactly one line, meaning if you put 2 points anywhere in space, you can draw one line. 3 non-collinear points, there's exactly one plane. So through any 3 non-collinear points, there's exactly one plane. That's something we just assume to be true. A line contains at least 2 points. That is something we assume to be true. It might have more than 2 points, but it has to have at least 2 points. A plane contains at least 3 non-collinear points. All right, it could have more than 3 non-collinear points, but it has to have at least 3 non-collinear points. If 2 points lie in a plane, then the entire line containing those points lies in that plane. So notice line AB is in plane K, so that means A and B have to be in plane K as well. All right, and then if 2 lines intersect, then their intersection is exactly a point. So that's another postulate. If you have 2 intersecting lines, they have to intersect in a point. If 2 planes intersect, then their intersection is a line. So think of the walls in your room where they intersect in the corner of the room, and that corner of the room is a line. So if 2 planes intersect, they intersect in a line. So let's look at some questions based on these postulates and some figures. So for this figure here, it's for questions 1 through 4. So question number 1, which option states the postulate that can be used to show that AC, sorry, it got cut off here. I should say AC lies in plane R. Oh, sorry. In plane R. Okay, so through any 2 points, there's exactly one plane, one line in a plane. That is not the postulate that shows that AC lies in plane R, because that is not one of the postulates. Through 2 points, there's exactly one line in a plane. Any plane contains an infinite number of lines. That is not a postulate. Through any 2 points on the same line, there's exactly one plane. That is not what the postulate says. If 2 points lie in a plane, then the entire line containing those points lies in a plane. That is one of the postulates. That is, if you look back at your notes, that is 2.5. So there it is D. So number 2, which option states the postulate that can be used to show that A, H, and D are coplanar? And it says through any 2 points on the same line, there's exactly one plane. No, because we're talking about 3 points. Through any 3 points not on the same line, there's exactly one plane, and that is true. If 2 points lie in a plane, then the entire line contains those points. No, but we're talking about 3 non-collinear points. And if two lines intersect, their intersection is exactly one plane. No. So we're talking about three non-collinear points. So it has to be B. Through any 3 points not on the same line, there's exactly one plane. Which option states the postulate that can be used to show that E and F are collinear? And if you look, E and F are here, and a line goes through them. So through any 2 points, there's exactly one line. That is true, yes. A line contains only 2 points. That is not a postulate. A line contains at least 2 points. If 2 points lie in a plane, the entire line containing those points lies in a plane. That doesn't state why they're collinear. Through any 2 points, there are many lines. That's not true. There's one line. So it is A. Number 4, which option states that the postulate that can be used to show that line DH and line EF intersect at point B? All right, so which postulate states that basically DH and EF intersect at B? Basically, 2 lines intersect at a point. So the intersection of 2 lines lies on a 3rd line? No. If 2 lines intersect, then their intersection point lies in the same plane? No, that's not necessarily true. The intersection of 2 lines does not lie in the same plane. If 2 lines intersect, then their intersection is exactly 1 point. That is what we're after. That's D. All right, number 5 for part A. So we'll look at this picture here. So it says points F and G lie in plane Q and on line M. So then it says, thus, line M lies entirely in plane Q. All right, so what postulate can be used for that? That says, if you have 3 non-collinear points that are 2 points, F and G, that are in plane Q and on line M, so we know that F and G are in plane Q and they're also on line M. Right? They're in plane Q here and they're on line M. So what postulate can we use to say that the line M is in plane Q? And it's the postulate that says if 2 points lie in a plane, then the entire line containing those points lies in the plane. All right, so then the next question says points A and C determine a line. Right? So remember, basically we're saying you have 2 points, you get a line. So there's a postulate that says through any 2 points, there is exactly one line. And then the next one, line AB and line BC intersect at a point, at point B. So basically what it's saying is that you have 2 lines and they intersect at a point. Well, the postulate that says if 2 lines intersect, then their intersection is a point. All right. So then next, we're going to look at some things on the next page and determine, are they always true, sometimes true, or never true? So for part A, it says, if plane T contains line EF and EF contains point G, then plane T contains point G. So basically, if a plane contains a line and then the line contains a point, then does the plane also contain that point? And the answer is it's always true. That's always true. Because remember, any point that's on that line is going to be in that plane if both points are in the plane. GH, which is a line, contains 3 non-collinear points. That is never true because remember, if it's a line, all the points are going to be collinear, not non-collinear. Plane A and plane B intersect in exactly 1 point. That is never true. Remember, the intersection of a plane is a line. Point N lies in plane X, and point R lies in plane Z. You can draw only one line that contains both points, N and R, and that is always true. Right, if they're in 2 different planes, let's say one's up here and one's down here, you can only draw one line that goes through both of them. That is always true. All right, so the next thing is the midpoint theorem, which says if M is the midpoint of AB, so we have segment AB, then AM is supposed to say then AM is equal to 1/2 AB and BM is equal to 1/2 AB. Basically what it means is the midpoint divides it into 2 segments that are half of the whole thing. And the questions here say, what is the difference between the definition of midpoint and midpoint theorem? Well, the midpoint theorem, the definition of midpoint says that you have congruent segments, meaning if you have a midpoint, it divides it into 2 congruent segments. The midpoint theorem says that the part is half of the whole. So basically it says that the 2 parts are half of the whole thing. So that's the difference between definition of midpoint and midpoint theorem. Definition of midpoint says that the 2 congruent segments, it would say AM is congruent to MB. That's definition of midpoint. But if you're talking about the midpoint theorem, that says that AM is half of AB and BM is half of AB. So basically, state the definition of congruent segments and give an example. Well, congruent segments are segments with equal length. So segments with equal length. So for example, AB equals CD means that segment AB is congruent to segment CD. If you're talking about definition of congruent angles, that means that they're angles with the same measures. So that means that if you say angle A is congruent to angle B, that means that the measure of angle A is equal to the measure of angle B. So that's the difference between, that's the definition of congruent angles, that if they're congruent, that means they have equal measure. Same with segments. If the segments are equal, then they're congruent, and vice versa. All right, so next unit, we'll talk about some more properties and postulates, and then we'll work our way towards making a proof. All right, have a good evening.